Picture a world where the United States finally seizes control of the electric vehicle revolution, where American innovation outsmarts the global battery Goliath, China. In the race for the future of transportation, can Detroit's giants rewrite the rules and bring affordable, long-range EVs to your driveway? Or is Beijing's hold on battery technology simply too powerful to break? Inside the pristine, almost eerie corridors of General Motors' Global Technical Center in Warren, Michigan, a quiet revolution is brewing. Scientists in full safety suits pore over test tubes and metallic machines, surrounded by long, spotless hallways and an air of secrecy more reminiscent of a high-tech biotech lab than a classic car factory. Just 30 miles away, Ford's engineers at the cutting-edge Ion Park Research Hub in Romulus are deep into their own ambitious project. Both companies are locked in an urgent race, one that could change America's place in the world of electric vehicles forever. For over a century, Detroit's automakers dominated the roads with roaring internal combustion engines. But the future, everyone knows, runs on lithium. Specifically, the race now turns on who can master the new generation of lithium manganese-rich, or LMR, batteries. These LMR batteries are seen as the key to unlocking cheaper, longer-lasting, and more sustainable electric vehicles, a crucial step if American carmakers want to compete with, or even outpace, China's battery juggernaut. Why does this matter so much? Let's take a quick deep dive. Today, about 85% of all battery cells for electric vehicles are manufactured in China. That nation also controls roughly 65% of the world's nickel refining and a whopping 75% of global cobalt refining. For the affordable lithium iron phosphate battery, better known as LFP, the US and even Europe are forced to buy almost every cell from China. Quite simply, China owns the EV supply chain. This dominance isn't just a business advantage, it's a strategic stronghold. As the world pivots toward clean energy and electric mobility, whoever controls the batteries controls the future. And it's not just about where batteries are made, it's about the raw ingredients, the costs, and the technology itself. Traditional EV batteries, like those using nickel, manganese, and cobalt in near equal parts, have powered much of the American electric fleet. But cobalt and nickel are not only rare and expensive to extract, they are also dominated by Chinese refiners. This makes every American electric car hostage to foreign supply lines, trade wars, and the unpredictable world of global politics. Enter lithium manganese-rich technology. GM and Ford are betting big that with less nickel, nearly zero cobalt, and a shift to manganese, a metal that's abundant, cheaper, and easier to process, they can break free from China's chokehold. At GM's so-called battery kitchen, engineers mix electrode slurries in what one scientist jokingly calls a high-tech baking session. Once these mixtures pass rigorous tests, they are sent for advanced trials at the Wallace Battery Innovation Center, hoping to create a cell that is both affordable and powerful enough for the cars of tomorrow. According to industry analyst Sam Abwelsamid, what we're seeing now is a technological shootout. GM's partnership with LG Energy Solution and their timeline for U.S. production by the year 2028 might give them a small edge, but both companies are pushing hard. This is as much about American industrial pride as it is about profit. It all sounds promising. The LMR design trims out the most problematic ingredients, offering a battery that could cut EV costs while boosting range and durability. GM claims their new prismatic cell could even deliver a 33% jump in energy density over current LFP cells. But there's a catch. Developing these batteries is an incredibly complex process. The chemistry has to work not just in the lab, but in millions of real-world vehicles. Scaling up from test batches to full factory lines takes years, mountains of capital, and flawless execution. And while Ford and GM work feverishly, China's gigafactories continue to churn out batteries on a scale that's almost unimaginable. So, can the heart of American industry really catch up to, or even surpass, the world's battery superpower? Or will the fuel of tomorrow still be stamped made in China for decades to come? So, what does the future hold as Ford and GM race to scale up their lithium manganese-rich battery technology? The stakes could not be higher. If these American automakers succeed, it could mark a turning point not just for their own futures, but for the entire U.S. electric vehicle industry. The dream of affordable, homegrown electric cars might finally move from vision boards to the highways of America. But the road ahead is still riddled with challenges. To reach true independence from China, Ford and GM must shift from promising lab results to the daunting reality of mass production. That means building factories, forging new supply chains for manganese, and, crucially, competing with China's relentless scale and speed. According to experts, China still controls roughly 85% of global battery cell production and three-quarters of cobalt refining. Even with LMR batteries, the U.S. will need to source massive quantities of manganese and set up advanced recycling systems to keep materials in play. If American companies can pull off these feats, the consequences could be profound. Electric vehicles could finally become as affordable and convenient as gasoline cars, and local manufacturing jobs could surge. As Sam Abwel-Samid of Telemetry Insights puts it, whoever cracks the code on durable, affordable batteries with great driving range will define the future of the auto industry, not just in America, but globally. But what does all this mean for you, the viewer? First, it's a reminder of how global economics shape the choices available in your everyday life, from the price tag on your next vehicle to the job opportunities in your hometown. If Ford and GM succeed, you could see more affordable electric cars, better performance, and more made-in-America options on dealer lots. You might even find new career paths opening up in battery manufacturing, research, or recycling as this new industry takes root. Second, understanding these technology shifts can help you make smarter decisions. If you are considering buying an electric car in the next few years, watch for news of these next-generation batteries. Vehicles powered by LMR cells could offer longer range or shorter charging times at a lower cost. And for those passionate about sustainability, advances in battery recycling driven by these technologies could mean greener options in the marketplace. So, can American innovation really overcome China's overwhelming lead in batteries and supply chains? The answer, while not a simple yes or no, is much more optimistic than it was even 5 years ago. Ford's breakthrough at Ion Park, GM's ambitious prismatic cell design, and both companies' commitment to U.S. production mark serious steps forward. While catching up with China will not happen overnight, the American auto industry has shown time and again its ability to reinvent itself under pressure. Here's a little-known secret. Manganese, the underdog in this story, is actually far more abundant and easier to process than both nickel and cobalt. This gives the U.S. a rare opportunity, not just to catch up, but potentially to leap ahead in building batteries that are cheaper, safer, and more sustainable. The real question now is not whether American companies can compete, but how quickly they can scale and win consumer trust. So, next time you see headlines about the EV battery race or walk past a new electric car in your neighborhood, remember, the real contest is unfolding in labs and factories across Michigan, with implications for the whole world. If you found this insight helpful, hit that like button, subscribe for more stories on global tech and economics, and let us know in the comments. Do you think the U.S. can close the gap with China in batteries? What would it take to win? Your thoughts